Okay, so here is the digestion short lecture for the final exam speed round. Also, if you have not been getting the emails, I sent out this PowerPoint. There is a separate PowerPoint for the kidney. There is a new outline study guide, and there is still going to be a new slide of repro, uh, ventilation, exercise, digestion, and kidney all together, which will be a little bit shorter than this for the kidney and the digestion part. But if you're not getting emails, I've been sending stuff out from the beach board. All right, so for digestion, there's only a few things that I need you to know. Most of it's going to be some anatomy of the stomach and some anatomy of the secretions and stuff that come out of the pancreas. So of course, for the digestive system, probably the most important things are understanding that the stomach is really not for absorption of food. I know that's kind of surprising. It's really for storage, so you can eat a big meal and then carry it around with you for a couple hours. It's for starting digestion of protein. It's for killing a lot of things that might be bacterial pathogens or whatever because it has hydrochloric acid, but it is really not for absorption. Absorption is handled instead by the small intestine primarily. So it's much, much longer. It has a surface which is really good for absorbing things, whereas the surface of the stomach is really protected against the acid environment more than anything else. All right, so those are the big ones for kind of understanding what gets absorbed, what doesn't, and where those locations are. Um, as you eat food, it might be kind of large things that you have to chew and break down in your mouth. And in the stomach, you sort of begin mechanical digestion, you begin chemical digestion, but not a whole lot of absorption. In the small intestine is when you have lots of absorption. You also secrete lots of things into the food to help break it down. So there's enzymes that break down proteins, there's enzymes that break down sugars, and there's things that can help absorb fat. So all that goes on. And then the large intestine, the purpose of this is really to then kind of take the big food that was small and make it big again so that you can excrete it. Whatever isn't absorbed goes out as feces. And so most of the colon's job is to absorb water out, which kind of cements this back into a mass that you can excrete. All right, so the stomach, we won't do too much with the anatomy of it. There are different regions and stuff like that. It's not really that important for the exam. More so, there are different types of cells in the stomach that all have special jobs. Like for instance, some of them will secrete mucus, which will protect the stomach. Some of them will secrete enzymes, which help break down proteins. Some of them will secrete hydrochloric acid, which is good for killing pathogens and also for breaking down proteins. So let's do all the different cells. Here they are. First off, the mucus cells, which are kind of near the surface, secrete like a water and a protein mixture, and when that kind of mixes all in the stomach, you get a mucus layer. So it coats the inside of the stomach. And that sort of slime is really important for protecting the cells from all of the kind of harsh chemicals that you have in here that could eat away the cells, and then you would get ulcers and bleeding if you didn't protect them. So the stomach is a tough place. It has very low pH. That's good for breaking down proteins and killing germs and stuff, but that's also really bad for cells unless you protect it with the mucus. All right, the next cells down are the parietal cells, and these secrete the acid. So the stomach environment of the acid is very strong. It's about a pH of 2, and that acid has to come from somewhere, and so hydrogen ions are secreted and it mixes with chloride and you get hydrochloric acid, which is nasty, nasty stuff, but your stomach can handle it. The other thing that comes from parietal cells is intrinsic factor, which we talked about in the blood lecture as being something that is required for the absorption of vitamin B12. Okay, you can skip ECL cells, and then chief cells, these things down here, secrete pepsinogen, which is a precursor for an enzyme that breaks down proteins. So know the mucus cells, know the parietal cells, and the two things that come out of that, and know the chief cells, which secretes pepsinogen. All right. The acid, like we said, has a couple of different functions. It does bring the pH way, way down, which breaks down or denatures proteins, kills things. Um, uh, uh, there could be harmful things on your food, germs, all that stuff. So this is nice and protective against that. The pepsinogen as an enzyme is not active until it hits the pH of 2. So pepsinogen is a precursor, and then pepsin is the actual enzyme. So that requires acid to do it. If you drop it in water, it won't turn on. It needs to be turned on in the acid environment of the stomach. Okay, so whoop-de-doo, that makes this digestion kind of the optimal thing for proteins. Okay. This is just to show you, pepsinogen comes from the chief cells. That's one of the cells in these gastric pits here. Hydrochloric acid comes from the parietal cells. The hydrochloric acid converts pepsinogen to pepsin. Pepsin starts breaking down your proteins into smaller peptides. There's no absorption here, but it just starts breaking them down into smaller things that your stomach can pass on to the small intestine. All right, so just remember these different conversions here. All right. There are issues with hydrochloric acid being very corrosive, and even the enzyme pepsin, it would begin to corrode the proteins of the cells in the stomach. So you need some type of defenses. The primary defense is simply having a slimy mucus layer on the stomach, and then also having bicarbonate, which neutralizes the acid. So if you lose this protective layer, you're much more at risk for ulcers. The cells are very tightly squeezed together so that this nasty fluid can't kind of get in between them, kind of leak down the cracks, and then get to the like the capillaries and things that are underneath the cell. So you want to keep them tight together, coat them with mucus, and then the last thing is that the cells have a very high turnover rate. So they get corroded physically, they get corroded by the chemical digestion in there, and so if you simply refresh those frequently, then you always have good, strong cells that are protective against all that. So from the stomach, you begin protein digestion because it's the first thing that anything hits as it goes from your stomach, but you don't absorb them. You also begin digestion of starches. This is in the mouth, so you have salivary amylase, which is an enzyme. It begins working on sugars in your mouth, then it hits the stomach and it turns off. So then you need to have something else begin doing that in the small intestine. But initially it's in the mouth, it's turned off in the stomach, and then it comes back in the small intestine. Okay. So after stressing that really nothing does get absorbed in the stomach, there are two common substances. The first one is alcohol, and the second one are non-steroidal anti-inflammatory drugs like aspirin, ibuprofen. Those things are NSAIDs. So that's it. No sugars, no proteins being absorbed, just alcohol and NSAIDs. So if you've ever been prescribed ibuprofen or something like that, they tell you make sure you eat it with food because it's very corrosive to the stomach lining. Some people go on aspirin for like a low dose regimen against cardiovascular disease. It's good for prevention of heart attacks, surprisingly. And they warn you that it can corrode the stomach, so you have to be aware of that. But that's it. Those are the only things that are absorbed across the stomach. Okay, so ulcers. You can get stomach ulcers. They're called peptic ulcers. And it's first, if you lose the mucus layer, then you can get down to the cells, and the hydrochloric acid can do more damage. Second, there are infections that can occur in the stomach that can reduce the stomach lining. So what you can do is take an antibiotic to try and knock down the bacteria, and sometimes that will cure your ulcers. Or the other thing you can do is try and shut down the acid. So there are some drugs like Prilosec that reduces the amount of stomach acid so that you don't have as strong a corrosion effect going on. So those are really common. All right. I'm not going to go through this, but you can read all these things about stomach ulcers if you're interested. All right, so moving on into the small intestine, where the stomach is really protected by mucus, by the tight cells, all that stuff against absorption. The small intestine is built for absorption. It has tons of folds, which is surface area. Each little finger that sticks up has even more little fingers on it, these microvilli. So it's just surface area on top of surface area on top of surface area. And it's built for absorbing things into lots of capillaries that lie just below the surface here. So this is actually a much more delicate structure. It doesn't have protection against acid. It doesn't have protection against a lot of the corrosive enzymes. So one of the first things that happens when things move from the stomach to the small intestine is you neutralize the acid with bicarbonate. So there are secretions that raise the pH from 2 all the way back up to about 9. So it knocks the acid straight down. So here's where that would happen. Coming from the stomach, you would hit the small intestine right here, and there are things that come from the liver, things that come from the gallbladder, and things that come from the pancreas. So the pancreas is going to be the main digestive secretion organ here. There's going to be enzymes, there's going to be bicarbonate, and all different types of things that work on the food or the chyme as it's moving through here. Okay. Just a reminder that out of what you eat, there is some water in it. So if you eat fruit and meat and things like that, there's water in there. But you lose water in a lot of places, so you have to be very efficient about recapturing that water. So saliva is like a 1.5 liters a day. Stomach secretions, acid, that's another 2 liters. There's bile, there's pancreatic secretions. And if this is not recaptured back into the blood, all of this is going to dehydrate you pretty severely. So you have to be able to get this back, and the bulk of it is occurring in the small intestine. The large intestine, however, is important for kind of finishing up the job and getting the last bit of water out. If you don't, you'll have diarrhea, and it's dehydrating. So things like cholera and dysentery kill people because they dehydrate them. And so one of the easiest ways to protect against it is simply to give people Pedialyte or hydration solutions to make sure that they're just not dying from issues with the large intestine. If you go too far, then the large intestine absorbs too much water, and then you're constipated because this is such a strong drying process here that the food clumps back up and becomes very difficult to pass feces. All right. All right, so on to the 3 main substrates: carbohydrates, fats, proteins, and how they're absorbed by the body. Just a reminder of the different carbohydrates that you might encounter: sucrose, lactose if you are eating dairy, maltose and a variety of foods, starch in lots of foods, any breads and potatoes and things like that, glycogen, which you could get from stored in your liver, stored in your body, but you also might encounter it in foodstuffs, and cellulose, which is made of glucose, but we cannot digest it. So you can eat cellulose, but it should not ever be anything that's broken down and absorbed. All of these are not simple sugars. Every single one of these is a disaccharide or a polysaccharide. The only thing that your body can absorb, and it's in the intestines, are monosaccharides. So you have to break down every single one of these things into something which is digestible. And so the only 3 things that you can absorb are glucose, fructose, and galactose. If you eat starch, it's a polymer of glucose, you need to break that down. If you eat cellulose, it's a polymer of glucose and you can't touch it. If you eat glycogen, you still need to break it down into glucose. If you eat sucrose, normal table sugar, it's glucose and fructose. You have to break that down. If you eat lactose, you have to break it down. If you don't have the enzyme to do that anymore, you are lactose intolerant, and you will instead, your intestinal bacteria will get to the sugar and they'll give you flatulence and diarrhea and gas and discomfort. So only glucose, fructose, and galactose can be absorbed. Okay. All right, what about proteins? Proteins are initially broken down, or you start digesting them in the stomach. You're trying to get them down into smaller fragments of proteins, so peptide fragments. And in the stomach, the enzyme that starts that is pepsin. Remember, it comes from pepsinogen. In the small intestine, there are more enzymes, trypsin and chymotrypsin. So remember, pepsin, trypsin, and chymotrypsin. And those come from the pancreas, but they're headed towards the small intestine. All right. Once you get them down into peptide fragments, you can break them down into individual amino acids, and there are special enzymes that do that. Carboxypeptidase from the pancreas and aminopeptidase from the small intestine give you individual amino acids off the end. So they chop off the final terminal amino acid so that those are then absorbed across the epithelial cells of the stomach and use them for protein synthesis, for substrate use, whatever you want. Okay, so you can absorb 2 or 3 amino acids at a time, if it's a really small polypeptide, but definitely not like a whole huge peptide. Everything has to be broken down into smaller chunks. Okay, all right. Last one is fats. Fats, however you eat them, tend to be large deposits, so a pretty big droplet of fat, and that's not easy to absorb. First thing you need to do is kind of get to this fat globule, break it down into slightly smaller spheres, and bile salts are key to doing that. So bile salts aid in the process of emulsification, which is breaking down little bits of this giant globule into something that you can then attack with enzymes. So here's your giant oil droplet. Lipase, which is an enzyme, and bile salts break these things down into ultimately monoglycerides and fatty acids, and those are absorbed across the small intestine. Okay? So here's the whole process from the top. Droplets get emulsified, they get broken down into smaller things called micelles, then that gets down into smaller free fatty acids, and you absorb this. Last fun thing to know about fat digestion is this does not go into the bloodstream. When you absorb fats, it goes into your lymphatic system, and then it eventually gets into your venous blood return. So it's not directly absorbed into the blood, it goes into your lymphatics first. Okay. All right, so that was fat absorption. The very last thing we're going to do is vitamins. There are 2 categories of vitamins. There are fat-soluble vitamins, which is A, D, E, and K, and then there are the water-soluble vitamins, which is everything else except for those 4. All the water-soluble vitamins can simply be absorbed with water. B12 requires intrinsic factor, which comes from the stomach, from the parietal cells in the stomach. Okay, and then last but not least, water is mostly absorbed in the small intestine, not in the stomach, and salts like sodium, chloride, potassium, calcium, iron, all these things are absorbed with daily intake, and you need to eat them, and mostly it's the small intestine that does it. Okay, so if I could summarize, here are all of the things that come from the pancreas that are important. These enzymes, trypsin, chymotrypsin, work on proteins. Carboxypeptidase is the terminal amino acid one, so it breaks off those final ones so that you get the smallest possible things for absorption. Lipase comes from the pancreas. It helps break down the fatty acids. Amylase, not salivary amylase, but pancreatic amylase, comes from the pancreas to break down sugars in the small intestine. And then ribo and deoxyribonucleases break down nucleic acids. So if you eat stuff that has DNA and RNA on it, you break it down, partly for protection against infection, but also that you can use those things for building blocks later on. All right. Last thing to say is about the liver. The liver has a ton of absorption things. We don't have time to talk about it. Works as a filter for blood. We don't have time to talk about that. It is the synthetic location for blood proteins like albumin, steroid binding proteins, clotting proteins, all that good stuff.